Hello, bSQL developers. In this video, I'll be going over how to create databases and the bSQL blockchains and their storage structure. So these are containers used for storing and interfacing with data. So right now, I'm logged into my instance. I'm currently connected to the master database. And because I'm the administrator of this account, I do have privileges to create databases. And any database that I create, I'm the owner. Therefore, I have all privileges on that database. Any blockchains that I create in that database, I still have all privileges on them. So I'm all privilege free. So I can go ahead and start with the simple command that is create database. So this is how we create a database. I'm just going to call this video. And I'm going to go ahead and give this a run. So as we can see, it executed correctly. And now I have this video database that's populated in my tree. One way that we can interact with this database is to use the fully qualified name in our commands. So if I were to say, hey, I want to insert into this, or I want to create something in this database, I can say, okay, I'm going to specify the video.container that I want to actually perform a mutation on, or maybe add an index to, and that's the fully qualified name. That's only because I'm currently connected to master. But let's say I wanted to actually use this database, and anything that I run is being done in this database. So I'm going to go ahead and type use video, and that's going to put me into this database, start my session on this database. Any command that I run will be on this database. So now my database has changed to video. So I'm currently interacting with it. And next step we're going to do is we're actually going to go ahead and create a blockchain. And blockchains are bSQL's kind of version of tables. So in traditional tables, they have three different kinds of commands that actually change data. They have an insert command, they have an update command, and a delete command. So the main difference between a bSQL blockchain and a traditional table is that in a bSQL blockchain, data cannot be physically overridden or wiped. So if you imagine I was using Postgres or SQL Server, when I would run an update and delete command, I would actually go in and override that existing data. Instead, using a bSQL blockchain, we actually just append that new version of that data point to the end of the blockchain. Therefore, we keep that immutable structure while still having that versioning functionality that you get with modern applications. So now I'm going to go ahead and switch on over to the docs and explain the different types of blockchains and what they're used for. So here we are at the docs page. I'm looking at this blockchain overview little tutorial. It gives you an overview of all the blockchains and their types. Like I was talking about previously, traditional SQL systems allow this kind of update and delete. Those commands actually physically override data. In bSQL, we're not allowed to physically override data. There's no way built into the system for you to physically override data. So instead of that update and delete, we use commands that are amend and discontinue. So this allows us to build an immutable log and store it and implement it in a few different ways. So the first blockchain type is the historical blockchain. It's not allowed to have a primary key, and you cannot run an amend or discontinue on that blockchain. So really, it's for logging data. It's for logging data immutably. So this barebone ledger is going to be faster than your other blockchains, and it's only going to keep track of data that you actually insert. On the other hand, a historical plus blockchain is basically the historical blockchain with an index built on it. So it allows for primary key references. It allows for foreign key references. Anyways, it's just built up a little bit more. Traditional blockchain is really the foundation of multi-versioning and time travel. It does implement the primary key, and it allows you to actually quickly access those old versions of your data. So this allows for you to go back in time and look at historical records and pull up those auditable trails that are provable. On the other hand, the sparse blockchain is very similar to the traditional, but instead of actually storing references to those old versions are stored in a sparse fashion. So if you think about a record updating and maybe you only update one single column, that only the updated column is stored, not an entire copy of that record. And if you're ever curious about what the different processes that go behind the blockchains are, I go through that in these tables. And these are helpful to understand, okay, what checks am I doing? What are the downsides? How long is this going to take? Because some can be a little bit more performance heavy. And if I'm ever curious about when I want to use a blockchain, from what type of scenario, I like to use this table down here, which basically describes how to use a blockchain. So now I'm going to hop back into the portal, and I'm going to show you the command for actually using blockchains. So now that we're back to the portal, what I'm going to do is I'm actually going to execute a create blockchain command. So I'm going to type out create blockchain. It's just like kind of a create table command in Postgres or SQL Server. So then now I'm going to specify the actual blockchain name, and we're going to call this, I don't know, tutorials. We're going to make it a sparse blockchain. And the sparse blockchain does require a primary key. So my first column in my schema is going to be a primary key. I'm going to call it ID. It's going to be of type UN64. And if you have any questions about schema or the types or certain constraints, I highly recommend that you look at this create blockchain command in the bSQL documentation, because we're going to make it a primary key. And it's also going to be auto-incremented. And auto-incremented is going to specify that every time I make an insertion, this count is going to go up by 1. So we're going to also have a tutorial name. We're going to make it a packed string. And maybe we'll have a, I don't know, number of views. And we're going to get so many views, we're going to make that a UN64. We're going to go ahead and give that a run and create our first blockchain. So there's a 17th blockchain, that's what that means. And let's go ahead and we'll find it. It should be in our sparse. There's our tutorials blockchain. Yeah, that's basically how you create a blockchain. In this tutorial, I went over the different types of blockchains, what they're best used for, what they actually require, how they're similar yet different to tables in traditional SQL languages. And in my next video, I'll be going over indexes in bSQL, how to use them, how to create a blockchain with indexes, how to attach indexes, what kind of indexes are built on the actual blockchains. Yeah, so I'll see you then.